The derivative does not always work the way that we would like it to when we're working with multiplication and division. We saw in the last chapter that constant multiples, addition, subtraction, those didn't pose that big of an issue. But when we're dealing with multiplication and division, we're going to have to approach these a little bit differently. So just to kind of illustrate why this is going to be a problem, I want to find the derivative of y equals 2x plus 5 times x minus 7. Now, if the derivative worked, the way I might want it to, I might just say, well, I can take the derivative of 2x plus 5, and then I can take the derivative of x minus 7, and then multiply those two together and call it a day. If I try to do that, I would say y prime, we'll say y prime with a question mark, equals the derivative of 2x plus 5, well, that's just going to be 2. And then the derivative of x minus 7, that's going to be 1. Well, 2 times 1, that's going to be just 2. So this is this my derivative? I don't really know. The thing about derivatives is that every function should have exactly one derivative. So it shouldn't really matter how we go about finding the derivative. In particular, if I wanted to simplify this function first and then take the derivative, I should get exactly the same thing as I did in this case, if this case works, if this thought process works. So I'm going to approach this problem differently here. I'm going to rewrite it down here. Y equals 2x plus 5 times x minus 7. Instead of finding the derivative right away, well, I can just FOIL this out. Shouldn't be too bad. I should have 2x squared, let's see, minus 14x plus 5x minus 35, or if I combine my like terms, 2x squared minus 9x minus 35. So all I did was simplify this function. All I did was FOIL this part out. Well, this is something that we're a whole lot more used to working with. That we can just use our power rule with. And if I use my power rule, I find that y prime is equal to 4x minus 9. Now, I know that when I found the derivative here, I didn't do anything that was, say, math questionable or math illegal. All I did, just to kind of reiterate, I FOILed first, and then I took the derivative just with the, that was a simplifying step. Then I took the derivative from here to here using the power rules that we have. Up here, this was highly, highly questionable because we didn't know if the derivative works out this way over multiplication and division. And it turns out, remember I said that the derivative, every function should have exactly one derivative. Well, here I ended up with a derivative of 4x minus 9. I know that's the derivative because I didn't do anything math questionable. All I did was FOIL and then take the derivative. Up here we said, boy, it would just be really nice if the derivative worked that way. And, well, we should get the same derivative in either case. Down here we got 4x minus 9. Up here we got 2. So in this case, it doesn't work the way that we want it to. The derivative does not, quote, distribute over multiplication or division for that matter. So we're going to have to come up with some other derivative rules that will help us deal with some of these cases. In this particular problem, 2x plus 5 and x minus 7, as we saw down here in this step, we could just FOIL that out into a form that we were more familiar with and then take the derivative. But in the last section, we introduced some functions that might pose somewhat of a problem for us. If I have, for example, y equals, say, x times e to the x power, here I actually have a function of x times another function of x. And I can't FOIL that out. There's no nice way to simplify that into a form that we're more comfortable with. So we're going to have to come up with a new derivative rule to handle examples like these. And we'll find out what that is in the next video.